As a child, I used to read a lot, like many of us here, and dream and long to have been born in a different era. Perhaps an Egyptian queen or a Viking warrior or a Greek philosopher. However, I am now utterly convinced that this period in which we are living now is by far the most interesting, fascinating, and unique period in the 4 billion years that life has been evolving on this planet Earth. So as a researcher in theoretical physics, quantum biology, data encryption, etc., I've had the luxury of living in the big picture, of having my career to ask big questions and to spend my days trying to ask them. But I feel now that this is a task that all of us need to take on, and not only those of us working in research in our offices in the basements of some university building, but all of us need to embrace this access to information and to knowledge, which we are receiving at an unprecedented rate. So as a physicist, I like to begin in the beginning, so I think you've all got pens and so on. It's going to be difficult for me to explain some of the later concepts without your basic knowledge of quantum mechanics, so no, I'm joking. So this big picture that I'm talking about starts with the very small and extends out to the very big. So I'm a quantum physicist, and what is quantum mechanics? It just deals with the very small particles like electrons, atoms, photons, molecules, and how they interact. So how small are these things? Well, in the middle, maybe you can recognize a human hair, which we're still able to observe with the naked eye. As we go smaller than that, we need technological assistance to be able to open up this aspect of reality to our observations. And next you'll see a DNA molecule, which we've only been able to picture in the last 50 years due to developments in observational techniques. And then if we go smaller than the nanoscale where nanotechnology exists, we get to the size where quantum mechanics plays a role. Now, as a quantum physicist, we've recently even applied quantum mechanics to the search for life off of Earth. So this is quantum astrobiology, and this extends from the pinprick size of an electron out to the edge of the universe. This is the field, the arena where we are searching for life off of this planet. And that's Mars that you may recognize on the left there, which is just 10 light minutes away, i.e. a WhatsApp message would take 10 minutes to travel at the speed of light to Mars. And at the very outer edges of the universe, that's almost 50 billion light years away, and the mind kind of starts to boggle at this point. So that's the setting for the big picture. And now, of course, I'm going to quickly take you through the biggest open problems in science very quickly, of course, and end up with something that you might recognize on the left. So let's start small. What are the big questions in the very small arenas? So our technologies are getting smaller and smaller. The miniaturization of computers and other technologies that we use, there's exponential growth in terms of how small these are getting, but there's also probably a limit. But at the same time, we don't understand the fundamental nature of the universe. In terms of a large portion of what the universe is made up of is called dark matter, because we have absolutely no idea what it is. So that's the very small. If we go up a step, we get to the size where kind of living systems exist. So the big question here is, how did life emerge? What exactly is life? We know that a living thing is different to the bunch of molecules that make it up, but exactly what is this distinction scientifically? So onto the scales where we interact every day, the scale of our planet, the scale of our lives, of our cities. We have huge challenges in terms of resource utilization. I mean, in my opinion, that's at the essence of the problems we're facing today, is exponential population growth with constant resources. So we need to up our game in terms of managing resource efficiency, etc. So when we become on a more meta level, so we've developed computing. We have, as living systems, developed a technology which will probably become more intelligent than us in the next 10 to 20 years. So how to define intelligence and what exactly this means are big open questions that you can write several PhDs on, but this is something we need to think about. What is the future of computing? Because as we know, this is permeating our life more than ever before. So the next question has a very simple answer. Yes. That's the question, whether I want to go and live the rest of my life on Mars, and the answer is yes. And why? I could go on for hours explaining why, and hopefully convincing many of you to join this mission to Mars. By the way, I'm not giving up my seat to any of those people without a fight, but the purpose of this slide was really to show what the Mars One project has achieved so far, which is really to have entered into the psyche, into popular culture. Lisa Simpson volunteered to go to Mars with the Mars One project. Sheldon Cooper volunteered to go to Mars on the Big Bang Theory. We have Zapiro Comics mentioning the Mars One project. And for me, this is, as I've said before, the most fascinating and exciting and unique era of existence on this planet. We're living in the middle of it. So I urge you to embrace these unprecedented, unforeseen accelerations and developments in technology, engineering, and science. Dream big, and remember Nelson Mandela's words, it always seems impossible until it's done. Watch this space. Thank you very much.